If we fast forward 10 years, right, do you think AI will run satellites and spacecrafts?
Especially when it comes to, let's say, very mission critical system like a Gaganyaan, right? There are certain things that nobody will allow any AI to take over. The nice thing about space tech is it's almost all the engineering disciplines combined, and you have a system which performs. Satellite constellations are evolving, and they're placing more and more satellites for that, and managing them without having some sophisticated intelligence is dangerous.
You told us about the great possibility of having data centers and computation capabilities right there in this space and not on Earth. What's the future of AI? Productivity hacks or chatbots? No, think bigger. Think AI is running satellites, making decisions in orbit, and unlocking possibilities that sound like science fiction today. In this episode, we are joined by Vishesh Vatsal. He is the Chief Technology Officer at SkyServe, a renowned space tech startup in India. Vishesh is an IIT Kanpur aerospace engineer who's pushing the boundaries of AI in space. Vishesh isn't just building tech, he's also shaping mindset through his popular blog on Substack, where he writes about hiring engineers, scaling teams, and building a deep tech culture. From scenarios that sound like sci fi to practical advices on how professionals should prepare for an AI first future, this conversation is all about bold, possible future of AI. Also joining me is my co host, Mr. Akshay Raj, CEO of Uno Labs. So, Vishesh, I'll start by asking you, when you hire engineers in your space tech startup, do you look for people who can code and at the same time people who can dream crazy?
Yeah, thank you for having me, everyone. So, yeah, to address your question, the boring answer is a bit of both, and for certain kind of roles, we would definitely need some level of skills, programming skills. But there would be certain roles where we look for, you know, more use of white coders, for example. You know, we know that certain tools would make you really productive. In fact, we encourage such behavior, but that is when you meet some minimum level of expectations. So I think from my experience, you need both, because while being great at programming fundamentals gives you a solid foundation, but your speed and productivity would come. And in fact, like, you are competing with other companies, or in this business environment, who are using the same tools as yourself.
Okay, thank you. Thank you, Vishesh. So, Vishesh, how do you build teams that are, ready for AI future, especially in space
Yeah.
tech?
Yeah. Okay. So, well, I'll come to space tech particularly because a nice thing about space tech is it's almost all the engineering disciplines combined, and you have a system which performs, lands on the moon, for example. And if you break it down, almost all the engineering disciplines are being disrupted by AI, which is a GPT. I I refer it to from academic literature as a general purpose technology, which essentially is penetrating every field, which is very surprising. And what I see is that a common theme that I notice from talking to colleagues, let's say mid to senior decision makers, which I wrote about in my article, is that almost everybody feels that having knowledge of some basic AI tools, for example, co-pilots or agents, or say, testing. These are things that would be needed in almost every discipline, and this is something that I would imagine that as a minimum AI first culture, you would have expectations that certain projects which used to happen, whose development period took months, uh, you don't have the same expectations anymore. You slightly, question, okay, do we really need all this time if you can actually become more productive? Clearly, that doesn't mean that you compromise on the integrity of your application. So, especially if it comes to safety critical applications, So these are things that I would say that come with some level of balance, but you need teams which have uh, some level of curiosity as well as strong fundamentals equally. And and also, I would also suggest that we need an AI skeptic in the team also, because there needs to be somebody who's the doubter. So that would really help.
That's a good point. That's a good point. There should be somebody, who shows the mirror and who is kind of acts like a devil's advocate, isn't it?
Absolutely.
Go ahead, Akshay.
Yeah. So, Vishesh, and thanks for, showing your interest and opening this forum, in the space tech. Because, see, in India, innovations going on in every field, and we were saying space tech is the place, where we are definitely India was lagging behind. So, good to see companies like, SkyServe being to, playing a vital role in the space, in the space tech. What role is AI playing in the space tech? Especially at midstream, upstream, and with the image sensing.
Mhm. Yeah, so there's so much to talk about. So let me just tell with one preface that AI was always there in space. We had certain narrow cases of AI, and these lunar rovers which have moved about in on the moon's surface. They have not been without path planning algorithms or computer vision, deep learning algorithms, or say some narrow applications of AI, which have always been there. Now, the rate at which we are seeing a lot of automation at every level, as you said, upstream, midstream, downstream. So in this case, for space tech, upstream refers to satellites or spacecraft, or so the applications there would be clearly autonomous operations. By the way, space as an industry is still shockingly conservative. uh, the fact that an object millions of miles away, it goes out of your control, is makes our scientists paranoid. So the fact that there is autonomy, these are very limited. But slowly and slowly, this is now penetrating more part of, let's say, mission operations, satellite health monitoring, for example. Then there are midstream where you get a lot of data which is coming down, let's say from satellites, and you are able to predict their health, and you can actually do something called predictive maintenance, which is otherwise applied all across our industry. It's going to now come with the AI plus premium long forecasting anomaly alerting systems, which is now seeming to be a trend that is inevitably in the horizon. And on the downstream, as you would imagine that if you're talking about data which is already here, this requires some pre-processing. Um, so you're talking about for imaging, you're pre-processing AI models, uh, finding out, say, for example, let's say a disaster which is happening right now. You need a proper assessment. Which are the most affected areas? What's the scope of the disaster? Can you imagine the amount of damage that is there? And these are all under downstream applications. Now, given the fact that space traditionally has been slightly closed, what we're seeing is because of AI, there's a lot of demand for data sets, and a lot of open data is there. So now we are seeing like every nook and cranny there's Earth observation model that somebody is making to solve one particular application, for example. So these are things that are happening at a very rapid scale, and as illustrated by examples, right? So it affects almost all the levels of upstream, midstream, and downstream.
Right, Vishesh. So Vishesh, would you please let us know, what is the more challenging use case right now, with downstream, upstream, and the image sensing?
Yeah,
It's one of the
interestingly,
most critical use
interestingly,
cases.
I personally have a heart in disasters, not because I enjoy them, but I think these are things that we have to solve. And as a country, we are very data poor. The number of satellites that we have a massive need to increase our data downlink. So, for example, by an order of magnitude or two, and that would be an application I'd be seeing that will have extremely high value. So the next time a major, let's say, weather disaster happens, we would probably have detected its risk and actually secured lives and property before that. So the amount of loss is colossal. So I think uh, apart from that, obviously, the challenges that would be solved will be strategic levels. So we are talking about possibly wars being fought tomorrow, so we have to have surveillance capabilities. These are things that obviously are discussed, thought about in policy circles, and clearly I see that there's a lot of action that's going on. By the way, India is currently in lower single digit percentage of overall space GDP. Uh, but to credit to our current policy, we are targeting something close to 10% or more, and that would require a massive, like really
Wow.
high rate of growth. So that would mean, say in certain sections, 30% compounded annual growth rates. So we're talking about a lot of investments, a lot of supply chain to be, secured. And clearly, there's the aspect that we have to have our own, let's say, models. For example, in this case, you need to have your own data sets. You have to have your own solutions to your local problems. And in this case, for let's say downstream remote sensing, uh, disasters, surveillance, and then obviously we need to have, let's say, good crop prediction. We need to have a good idea of, let's say, uh, how is the crop health over the coming cycles, and we've got like plenty of great companies in the Indian ecosystem for that. So a lot of things are being learned. Policies, like earlier, what used to happen was there was no space policy itself, which was very encouraging for private companies. Now is when something called new space companies which are coming, who are taking more risks, and they are also having a say in the policy making. So this is quite welcome, and I feel that it may lead to a time where we can be very proactive to things which can be seen from space. So I am genuinely positive about this.
So thank you, Vishesh. I think, yeah, I think we have a lot of aspirations, no doubt about it, and I think we will be able to achieve. Looking at the past record in space tech, we have done very well. Considering the organizations that we have, government organizations, ISRO, right, and other startups that have come up. I think the goal that the policymakers have set, I think it is achievable. But let me ask you some interesting questions. So if we fast forward 10 years, right, do you think AI will run satellites and spacecrafts autonomously without much human intervention?
Uh, so let's break it down. So maybe for everyday audience, I think I would say that there are many parts of the overall satellite operation chain. So say, for example, as of now, if you want to take a picture of Bangalore, for example, you have to plan this before, and you have to uh, inform your satellite operator that, hey, I want to look at this picture of Bangalore in this week. And this input is used to inform what operations the satellite will schedule for itself, including taking an image of Bangalore, and somebody else will be asking for something else. So you have to actually manage that. And as you can see that these are possibly operations problem which can be easily disrupted by AI. But oftentimes it happens that conventionally there used to be a team of mission operators who used to manage this. And uh, but let's say, for example, if you're flying right now above Bangalore, you might just see just clouds, and the image that comes down, it's not so useful anymore. So operations wise, then you have to then replan an acquisition while looking at how the orbital dynamics evolve, how the satellite will come to the same place in a similar geometry that you like. And these are the kind of problems that you have to solve. However, that being said, um, the automation here would be that first, the amount of time and effort that is spent on ground has to be well defined. You need to have clear rules, and then planning, operations, optimization. These are things that AI is relatively good at. And especially when it comes to, let's say, very mission critical system like a Gaganyaan, right? there are certain things that nobody will allow any AI to take over, because these are human lives at stake. So there's a certain amount of risk that you are able to take when it comes to, let's say, robotic spacecraft which are just flying around the Earth. So those are the places where there's more disruption possible, where satellites can intelligently, for example, look at the data that they've just captured from above and recognize that it's not of good quality. This is just 90% clouds, and it should be able to discard them. Then following that, it should be, let's say, for example, if there are no clouds, rather than looking at just the image, you might be just looking for a forest fire. And in other words, rather than scheduling a downlink, sending something to ground as 1 GB worth of image data, you just might want to send very useful message packets, which could be kilobytes worth of this. But all of this, by the way, every link between operators and ground stations is coming at a kind of similar to mobile rates, some dollars per gigabytes. And these are things that you can genuinely avoid, because a lot of crap data also comes down. If, let's say, for example, the end purpose is not for scientific analysis of clouds, for example, so you can do a lot of automation and bad data discard, operations planning, operations automation, with the capabilities that AI brings. So that's how I would sum up. I would say that with all of that, some caveat that there are other things involved that are no, as a technical brain, I have no grasp for, because there are jobs at stake. There are a lot of implications for people. So there'll be things that will happen at some slow, gradual pace, depending on the amount of risk that, let's say, an entity can take. So that's how I would put it.
Okay, thank you, Vishesh. So, what I'm hearing is that more and more of AI in space, right, on satellites, will help. Mostly, you're saying that it will help in disaster management, right? In a faster
Not
response to that.
necessarily. I'm saying disasters. There's basically strategic applications,
Right,
a
right.
bunch of other applications, but I would say that specifically these applications are prone
Right.
to disruption now, as in they are
Right. But
high value applications they would need now.
but you mentioned that still there will be some missions like the Gaganyaan where human lives are at stake. We may not have AI intervention to that level, right? Um, I read your blog, so you've written that you believe that the more and more computation will happen, onboard satellites rather than the raw data being sent and then we apply the AI on that sitting
Mhm.
here, right? What is that? What is that logic, and why do you think this will happen?
Yeah, as I said, so that there are there are a lot of things that you can do. So you may have the best internet, right? Let's say you have like a really high 10 gigabits per second line between satellites, and it's like almost a real-time CCTV from space. But there's today that data comes at a cost, and you given the projections that I'm seeing, you're talking about 2,000 petabytes of data per year. With we are launching potentially plans of 50,000 satellites in 5 years or more. So there's a lot of data, and also the amount of the volume of the data is growing very fast. You're talking about higher resolutions, higher spectral bands, different kinds of data. So what I see is that one of the very first application would be data compression, quality identification, discard of bad quality data. Then I would see that it clearly makes sense that you have capabilities of computing which were traditionally on available only on ground. So, say for example, a 16 gig GPU, available in space. This is something that is possible very soon. And one of the reasons that is possible is that satellites being relatively, coming in different sizes, power constrained systems. You don't have infinite power, but you need edge computing, which have just barely at least meets your demands for, let's say, calculating deep learning model inference. So this is something that is possible today, and I think I've argued enough times that you have all the capabilities that you need to at least do many parts of the capabilities that I'm talking about. So they are there. And by the way, deep learning has been around for what, 10, 15 years now. To be precise, like something close to 11, 12 years. But satellite industry traditionally had been designing it in a very conservative way, that we wanted data to be produced in space and to be sent down in a bent pipe architecture, where it's just point and shoot and just send down. And if, let's say, 50% of this data is cloud, right, you're literally wasting a lot of bandwidth and cost. Expenditure is up, and that's one of the reasons why high resolution data, when it lands up to the user, it's not so affordable. You're talking about one image that you're looking for is $400, and that's why you don't see industry-wide adoption of this data continuously. And that's something that I feel that because of capabilities of AI on board, there'll be a larger term cost implication also, which can come down. It can actually become more democratized. Now, a crazy possibility coming in the future is the fact that the satellites are literally consuming the solar power, right? And we're talking about satellites can be big as hundreds of kilograms or tons also. And the fact that you can generate like near infinite power in space, why not shift our data centers up in space itself? And no need to bother answering to climate activists about the energy implications of your data centers. You need have some kind of energy. So basically, you need to launch it out to space. But if you have this, it's just that now you are in a vast universe, and that's doing the computation for you. And this is something that I feel that it's so logical, and it seems that it should have been done. But now we have two, three things happening together. The launch cost, because of SpaceX, has come down significantly. That people can just throw shoebox size satellites in a few crore rupees worth of development costs, and then hence like there's a lot of data being produced. But then on top of that, there's space policy, which is now understanding that hey, we can do many things more rather than restricting ourselves to just this or that. If you see the latest space policy, we have like super encouraging policy for entrepreneurs. They're literally asking us to, if you want to do an asteroid exploration, you can do that. And the third part, I would say, is the fact that uh, deep learning's advent has been 12 years into it. Now we have compressed models which can run in space, even in potentially energy constrained environments. You have many things going for it, and those are things probably will lead to what I was talking about.
Hmm. Actually, my next question was that is there any sci-fi kind of theory in AI that you think will be possible in our lifetime? And I think you have answered that. You said that maybe in our lifetime there is a possibility that data centers are placed in space, maybe on another planet. We don't know, right? But do you really think? Let me ask you again. Do you really think this is possible in our lifetime? Do you see that? Do you see
Yeah,
that happening?
I would say that's it has a 90% chance of happening for sure. I think I don't see any physical constraint which couldn't happen, and especially the fact that when you know that there's some fundamental level of changes, the energy like you have like as per computational energy costs involved, like you have something called Landau's constraint. So you have like which is way into the future, which will basically restrict you that how much compute can you do with this amount of power. And it's like not even a question that we are arriving at in our lifetimes. And that's what I see, that uh, is there any physics constraint that stops us? There's a lot of power in space. There's nobody out there. It's a dangerous environment, so probably it's best that machines do it. A lot of implications which are there with respect to having data centers, increasing our average energy cost, that won't be there anymore. So these are things that I see that generally should be possible. I don't see a very, unless there's a very anti-space movement or I mean something unpredictable. I see that's highly likely to happen.
This is great. This is great. Kind of food for thought that you have given us. You have also written about, through AI, satellites can work in sync like a constellation, right? Rather than sending one big satellites, we'll be starting to send smaller satellites which will work in sync, fully automated, and there will be minimum manual intervention. Tell us more about it.
So yeah, as in we are talking about a space which is humongous, and we have right now thousands of objects. Some of them are active satellites, some of them are debris, some of them are actually asteroids, or say meteorites floating about. So we've got a very interesting environment out there, and one of the challenges is to think about, like, why are we throwing so many satellites? And if you think about three dimensions, right? One is the temporal frequency. So how often can I see, let's say, the Panama Canal today with the kind of satellites that we have? Typically, when if a single satellite comes, if it's in something called a lower Earth orbit, specific inclinations, you can see that in about a week. So the next time you come at a very, very nice proper geometry, you will see that in a week only. Now with add that two satellites, 5, 10 satellites. Now you're talking about hours, right? Tens or hundreds of satellites. So you will see that that's one problem, that's this temporal frequency that's going to be solved. I mean, Earth observation or space tech would, specifically space tech for Earth observation, would end when you have like live HD footage in every spectrum, let's say 20 years down the line. So you like, it's like an all pervasive CCTV on yourself. Uh, Sounds a little dystopian, but yeah. but yeah, the point is that the constellations attack one problem, which is the temporal frequency. The second problem is different constellations have different purposes. One purpose is also, let's say, for example, if you've got an optical system, you're talking about different wavelengths that you're trying to capture. And human eye can only see something close to 400 to 700 nanometers. And then you're talking about companies, let's say a company like Pixel would look at much larger wavelengths, where interesting possibilities arise, like things like mineral discovery, or say looking at fire hotspots or volcanic eruptions and so on. So these are things that are needed. Their applications are now emerging. And so this is the spectrum dimension, which is now will be solved by, let's say, a satellite which is working on a specific kind of sensors. Then there'll be satellites which have radars and so on. So the third aspect I see is the resolution. So how clearly can you see an area that you're looking at? If you're looking at, say, something like hundreds of meters per pixel, that limits the amount of things that you can do. So if you're able to get to, let's say, a few tens of centimeters per pixel, it opens up a world of possibilities. You could look at, which red color car is, parked wrongly, for example. I mean, we still cannot see pimples on the face of somebody, but maybe it will happen also in the future. But that's the point, that along the three dimensions of frequency, the purpose of the sensing, as well as the resolution, satellite constellations are evolving, and they're placing more and more satellites for that. And it is now being done by private companies. It's being done by governments. Chinese, if you are to believe, they are planning millions of satellites, and whether it happens or not. But let's say if you're thinking about it, this is a problem of a huge number of satellites which have to be orchestrated together, and managing them without having some sophisticated intelligence is dangerous. And I think one of the basic things is, let's say, satellites can also collide with each other. That's a traffic problem also that's potentially incoming. And there are certain altitude ranges above the Earth where, if certain collisions happen, you might have seen the movie Gravity, things can escalate. It's like an avalanche effect called Kessler Syndrome, which will, essentially just split apart almost all things that are there in those zones. And you're talking about a big fat shield around Earth, and cannot do a lot of things then. So the good thing is that the number of satellites today is less, few thousands on such a large planet, just small dots today. But things can change in the future. And maybe it's a few decades away, but yeah. So the point is that with constellations, you have to manage them. You have to have some level of autonomy and intelligence, that they can take some decisions of their own. But these are very complex, sophisticated systems that it's not necessarily humans alone will be able to solve it.
it is good to see, that as you said, India is now into, global AI race, for each and everything with respect to the space check, we are totally dependent on NASA. Now, we are able to build our own ecosystem in the, in space. So, this is my next question to you is, what role do you see India playing in the global AI race, especially when it comes to deep tech and space technology?
Yeah. Yeah, good question. As in, I see that today there's the contribution to the global economy, and it comes from a various parts of segments of what is space tech in India. You're talking about, let's say, satellite communications. You're talking about Earth observation. Talking about many things which, let's say, weather monitoring itself, right? Which we are affected by, but it is kind of in the background for us. So I'll tell you one very interesting example. Uh, you might have seen that the reports that, hey, NASA publishes this crop burning image, and it does detections of when let's say fires in Punjab, specifically the farmers are actually lighting it up. And it's done by a set of satellites that NASA has. And it's very likely that, by the way, all of this data is used by Indians also, and integrated and distributed across a lot of people. It's also used for detecting forest fires, for example. Uh, the data is actually very high frequency but slightly low resolution. uh, it could happen that this set of satellites get decommissioned and this data feed is switched off. And what do you do as a country then? Right, so you need to make sure that you have backups for things that you are like by default reliant on external data sources from for. So in this case, you would probably need a small satellite constellation which has relatively lower cost to build, but you can do very high frequency monitoring of such kind of disasters, for example. Then I mean, the crop burning is not a disaster per se, but like you need to have constant monitoring and intervention. But wildfires could, if not detected early, 90% of these wildfires, by the way, are anthropogenic, caused by humans, according to Forest Survey of India. So you need to act quickly and detect them, and if you are having the capability to address them, respond quickly. So you need to have such kind of capabilities by making your own indigenous constellations. So what's happening is particularly led by the policies right now. There's a decent amount of investment that's coming into space, which can allow these kind of solutions to come in. So that would mean that we have our own constellations, which for different purposes, and this also means that not necessarily relying on everything from outside. So that's good. But think of a more optimistic use case. What if actually we are taking this to the next step, where we are actually giving this as a service for the world? In fact, that's how we should probably imagine it. That these are spaces not restricted to just India. These things are relevant for other countries also, and this is something that, as a role, I think that Indian companies would also play. I would just want to point out one of the things that I used to work on is called the LIS-4 sensor, which is an ISRO satellite which was launched. It actually released one of the highest resolution open data sets in the world. And this is at 5-meter resolution, which was like even the US did not open it up. So we have at least taken some measures which are actually very encouraging. And I think take 2 or 3 steps down the line, you are seeing very ambitious global companies coming out of this. And that's where I see that I generally am seeing that there's a lot of things that we're solving as our own problems, which are applicable for many places.
So, Vishesh, everyone talks about AI in finance, healthcare, and today we are discussing, AI in space tech. But can you tell us about any other industry where AI you see could totally change the game, and nobody's looking there?
Yeah. Bangalore traffic and real problem. We have got a lot of data.
Yeah,
It
true.
can be solved. We've got I mean, it's being addressed in some ways by intelligent, let's say, traffic lighting, could be navigation. In fact, like I have written a small paper about that, where even satellites could support. Let's say, tomorrow we can detect potholes from space. In a single image, you can get an entire snapshot of the city, and feed this to Google Maps navigation API, or say, we can set up, let's say, a small smartphone in autos which can look at susceptible uh, trees susceptible to monsoons, for example, which can fall. Um, there's so many creative solutions that can come up, but you need to think a few steps ahead here. But I think there'll be more and more such solutions which can be addressed through AI. And I mean, there's always a case that it will never be good enough. I hope the metros come in. It's not just everything is in AI's control. Um so for now, you would probably choose to just meditate in a traffic jam. But yeah.
That's a brilliant point. I think this is something that nobody is thinking about. Everybody knows there is traffic. Everybody gets stuck every day. But yeah, that's a good point that we can even use AI to solve that. And why not traffic? Why only traffic? But I think at some point of time AI can also solve our whole urban infrastructure problem, right? So brilliant. I mean, a combination of AI and space tech. Maybe someday we'll use it in a way that it solves our urban infrastructure, isn't it? Okay.
Yes. All
So
for it.
Vishesh, so Vishesh, after all this conversation and a great conversation that we had with you, I'll ask you a very important basic question. Do you trust AI? And if you do, till what level?
Hmm. Um, Well, I don't trust most humans, so it's a word for meant for humans. Otherwise, like if I see this in an abstract way, we're talking about some software in a data center, some model weights doing something, and behind that there will be a team which has kept a biased data, or say objectives have been. So in that way, I would say that yes, in an abstract way, yeah, it's not a question that applies so well. But you look at, let's say, very in a very narrow way, that let's say, do you trust what uh, get from a GPT-4? From whatever I've heard, on the alignment problem, there are many issues. There are It's known that AI has fake data, fake knowledge. Although with different set of inputs, it it knows the true knowledge also. These are things which are slightly make you uncomfortable. And also on a larger way, in a larger way, I would say that these are very sophisticated models. It's hard to explain, and hard to control. If things don't go well, that would be really, really bad outcomes. It's uh, just we need to invest, especially all the people who promote AI like shit. Sorry, but they none of them are putting the equal amount of emphasis on making safeguards, right? And or investments. The investments are completely like an arms race right now, and yeah, this is slightly scary. Yeah.
Hmm, okay. So let me end at this point, asking you that taking both sides of the coin, right, positive and negative of the AI. If you had to describe one crazy but very possible AI future headline, maybe in let's say 2040, what that headline would read?
um, a version of AlphaFold cures all diseases. That would be awesome.
Really nice. Thank you, Vishesh. It was a great conversation with you. You told us, right, how AI was being already utilized in the space tech, but now India has set ambitious goals of making its space tech very AI enabled in a very big way, right? And also the most interesting part that I thought was you told us about great possibility of having data centers and computation capabilities right there in this space and not on Earth. So let's see. There are many possibilities, and we also pointed out kind of some negative points as well, and ethical issues as well with the AI. Let's see where it goes. So thank you, Vishesh. Thanks for your time.
Thank you so much for hosting me. I hope that It was as productive as it was for me. I think I had done a lot of homework for this, but the one thing that I couldn't do is to be as well dressed as you guys.
I told you already, we are overdressed. Thank you.
Thanks, Pratik. Thank Akshay. Bye.